Good morning, students. Today we learn the chapter Inverse Trigonometric Functions. Before going to this, we must know about a function. Function is a relation between two sets in which every element of first set A are uniquely associated with the element of set B. Now, inverse of the function. The inverse of a function f inverse exists if f is 1 1 and on 2. It means if f is a function a to b, then its inverse f inverse will be the function b to a, and it is possible only when function f is 1 1 and on 2. Here domain of f is a and codomain is b. Its inverse function f inverse such that b to a is possible if codomain of f is equal to range of f. Hence f must be onto, and every element of codomain of f is equal to, that is the range of f, must be associated with pre-element of domain of f, that is a, uniquely. So f must be 1 1. In function f has domain a and range b, then inverse function f inverse has domain b and range a. We know that trigonometric functions are periodic functions. These are not 1 1 and not onto over the natural domains and ranges, and hence their inverses do not exist. Suppose f such that r to r defined as fx is equal to sin x, means sine function, that is trigonometric function. It is defined r to minus 1 to 1, that is the range of sine function. Then sine inverse will be minus 1 to 1 to r. It is not function because as we take an example, sine pi by 3 is under root 2 by 3 by 2, and sine 2 pi by 3 is also under root 2 by 3. So root 2 by 3 has two pre-images, pi by 3 and 2 pi by 3. It means the function is many 1. So its inverse, sine inverse root 3 by 2 has two images. That is against the definition of function. So inverse is not a function in case of trigonometric function. Now some restrictions on domain and ranges of trigonometric functions which ensure the existence of their inverses. We take some restrictions on domain and ranges of trigonometric function so that we can define inverse trigonometric functions. Trigonometric functions and domain and their ranges are here. Sine function that has domain r and range minus 1 to 1. Cosine function cos domain is R and range is -1 to 1. Tangent function tan theta, tan x, domain R minus x such that x is equal to 2n plus 1 pi by 2, n belongs to z to R. Similarly, cot function, sec function and cosec functions have their different domain and ranges. Since the domain of sine function is the set of real numbers and range is closed interval -1 to 1, if we restrict its domain to minus pi by 2 to pi by 2, closed interval minus pi by 2 to pi by 2, then it becomes 1 1 and on to with the range minus closed interval -1 to 1. As sine function such that closed interval minus pi by 2 to pi by 2 to closed interval -1 to 1, then sine inverse will be as closed interval -1 to 1 to closed interval minus pi by 2 to pi by 2. We can therefore define the inverse of sine function in this interval. We denote inverse of sine function as sine inverse, and this is also read as arc sine function. Thus, sine inverse is a function whose domain is -1 to 1, closed interval, and range is closed interval minus pi by 2 to pi by 2. This is called principal value branch of this function. It has also some other branches, but here we study about the principal value branch only. We write sine inverse function is such that -1 to 1 to close interval minus pi by 2 to pi by 2. From the definition of inverse function, it follows that sine inverse x, that will give you x if x lies between -1 to 1, and sine inverse sine x also give you x if x lies between minus pi by 2 to pi by 2. Suppose we have y is equal to sine inverse x, then what happens? It means sine y is equal to x. This is the method. The cosine function is a function whose domain is the set of real numbers and range is also closed interval -1 to 1. If we restrict the domain of cosine function to closed interval 0 to pi, then it becomes 1 1 and on to with range closed interval -1 to 1. As cos function such that closed interval 0 to pi to closed interval -1 to 1, then cos inverse function such that closed interval -1 to 1 to closed interval 0 to pi. The cos inverse such that, thus we write, now here closed interval 0 to pi is called principal value branch of function cos inverse, and we write it like this: cos inverse such that -1 to 1 to close interval 0 to pi. And similarly for other trigonometric functions as tan x, cot x, sec x, cosec x also. Now there is a table which gives the inverse trigonometric functions, principal values along with their domain and ranges. Sine inverse function, domain is closed interval -1 to 1. 2. Range is closed interval -π/2 to π/2. Cos inverse function, the domain is -1 to 1 and range is closed interval 0 to pi. Cosec inverse function, domain is r minus -1 to 1 open interval to close interval -π/2 to π/2 minus the set containing 0. Sec inverse is the function, domain r minus open set -1 to 1 to close interval 0 to pi minus the set containing π/2. And similarly, tan inverse function, domain is r and range is open interval -π/2 to π/2. And similarly, cot inverse the function, domain r and range is 0 to pi. Now we must know sine inverse should not be confused with sine inverse sine x whole power -1. In fact, sine x whole power -1 gives you 1 upon sine x. But sine inverse x is not 1 upon sine x. It is the symbol of inverse trigonometric function. And similarly for other trigonometric functions as cos inverse x, tan inverse x, etc. Now a concept is there. The principal value of sine inverse, tan inverse, cosec inverse are the angle lies between -π/2 and π/2. The principal value branch of these three is closed interval -π/2 to π/2. That means first and fourth quadrant. So the positive values of x as sine inverse x, tan inverse x, cosec inverse x, in this case we search the angle in first quadrant, and for negative values as sine inverse minus x, tan inverse minus x, cosec inverse minus x, we search the angle from fourth quadrant, and that is the angle negative from fourth quadrant. Second concept is the principal value of cos inverse x, cot inverse x, sec inverse x are the angles that lie between 0 to pi. It means their principal value branch is 0 to pi. That is first and second quadrant. So positive values of x as cos inverse x, cot inverse x, sec inverse x, we search the angle in first quadrant. And for negative values as cos inverse minus x, cot inverse minus x, sec inverse minus x, we search the angle from second quadrant, and that angle is like pi minus theta. Example, sine inverse minus half, that is equal to minus sine inverse half is equal to minus pi/6, as this is minus pi/6 belongs to minus pi/2 to pi/2. So this is its principal value is minus pi/6. But cos inverse minus half is equal to pi minus cos inverse half, that is pi minus pi/3. Cos inverse half means half of the angle whose cos is half, that is pi/3. So pi minus pi by 3 give you 2 pi by 3, as 2 pi by 3 belongs to 0 to the set, closed set 0 to pi. Now I am taking an example with the concept of above 2. Find the principal value of sine inverse 1 by root 2. Let sine inverse 1 by root 2, that consider it at y. That means sine y is 1 by root 2 is equal to sine pi by 4. Pi by 4, sine pi by 4 is 1 by root 2. So y is equal to pi by 4, as pi by 4 belongs to minus pi by 2 to pi by 2, principal value branch of sine inverse. Now come to second example. Find the principal value of cot inverse minus 1 by root 3. Suppose cos inverse minus 1 by root 3 is y. So y, cot y is equal to minus 1 by root 3. So minus cot y is equal to 1 by root 3. We know that the range of principal value branch of cot inverse is 0 to pi. So minus cot y will be written as cot pi minus y is equal to 1 by root 3, and that is cot pi by 3. 1 by root 3 is cot pi by 3. So the angle pi minus y is equal to pi by 3. Thus we get y is equal to pi minus pi by 3, that is equal to 2 pi by 3, which is belonging to the principal value branch 0 to pi of cot inverse x. So this is the answer. Now I am taking some exercise questions. Find principal value of the following. First, sine inverse minus half. Solution: sine and minus half is the value of sine pi by 3. And we know that the principal value of branch of sine inverse, tan inverse, cosec inverse are the angles that lie between minus pi by 2 to pi by 2. The principal value branch is closed interval minus pi by 2 to pi by 2. So this is sine inverse sine minus pi by 3, as minus sine pi by 3 becomes sine minus pi by 3, angle from fourth quadrant. So we get sine inverse sine removed, we get minus pi by 3, and minus pi by 3 belongs to closed interval minus pi by 2 to pi by 2. So its principal value will be minus pi by 3. Now there is another question, question number 9 from the exercise. Cos inverse minus 1 by root 2, that may be written cos minus cos pi by 4, as 1 by root 2 is the value of cos pi by 4. So that is equal to cos. Now minus cos pi by 4, we find this angle from second quadrant, because the principal value of cos inverse, cot inverse, sec inverse are the angles that lie between 0 to pi. So negative cos will be in second quadrant. So this becomes cos pi minus pi by 4. That is, removing cos inverse cos pi minus pi by 4, that removing cos we get 3 pi by 4, and 3 pi by 4 belongs to 0 to pi. So principal value is 3 pi by 4. Now a question is from your exercise 11th. Tan inverse 1 plus cos inverse minus half plus sine inverse minus 1 by 2 is equal to, what is the value? Write like above. Tan and 1 is tan inverse, and 1 is tan pi by 4. So you write tan inverse tan pi by 4 plus cos, and here cos minus, and half is the value of cos pi by 3. So you write cos inverse minus cos pi by 3 plus sine inverse minus sine pi by 6, as half is the value of sine pi by 6. Now this becomes tan inverse tan pi by 4 plus cos inverse cos pi minus pi by 3, because the cos inverse has principal value branch in second quadrant, and minus cos will be in second quadrant. Principal value branch is 0 to pi, and negative value of cos will be in second quadrant. So cos inverse cos pi minus pi by 3 plus sine inverse sine. Now minus sine has its principal value branch minus pi by 2 to pi by 2. So minus sine will be in fourth quadrant. So this will be written sine inverse sine minus pi by 6, and this is equal to, removing tan inverse and tan, we get pi by 4, cos inverse and cos pi minus pi by 3, sine inverse and sine removing, we get minus pi by 6. Adding all these, we get 3 pi by 4. In this way you can solve the exercise. You have practice questions, and do it accordingly. This is new chapter, so one graph is I have drawn in this sine function and sine inverse. Similar way you have other functions graph on your textbook, you can see, and mainly you will be attentive for solving questions. That's all. Thank you. Good day.